Hello and welcome to Maths with Jacob. This lesson will focus on special curved graphs. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. If you would like to subscribe now, please do so here. Otherwise, you can subscribe at the end. Nonlinear graphs. We have seen many examples relating to graphs of straight lines. In this video, we will look at 4 special curved graphs. Graph 1. The first graph is known as the rectangular hyperbola. It is of the form xy equals a, where a is a constant. In real life, a household lamp casts hyperbolic shadows on a wall. The hyperbola is the basic design for all nuclear cooling towers. The hyperbolic shape allows them to withstand high winds. The above curved graph has the specific equation xy equals 8. It is important to note that the graph does not touch any of the axes. The two axes are called vertical and horizontal asymptotes at x equals 0 and y equals 0. So you can see as the curve approaches this way and that way, it becomes very close to these axes but never touches them. And the same in this case here. And that's why they're called asymptotes. Graph 2. The second graph is referred to as the exponential function. It has the general formula y equals n to the power of x. Population growth, radioactive decay, and loan interest rates are a few examples of naturally occurring exponential relationships. The above exponential graph has the specific equation y equals 2 to the power of x. Notice that it also has an asymptote at y equals 0. So as the graph moves in this direction, it never meets the x-axis, and that's why it's called an asymptote. Graph 3. The third graph is known as the logarithmic function. It has the general equation y equals the log of x to base b. Logarithmic functions have many applications in the real world. They are used by financial institutions in calculating interest rates and investment growth. The Richter scale relating to earthquakes and decibels relating to sound also rely on logarithmic functions. The above graph has the specific equation y equals the log of x to base 2. Graph 4. The fourth type of graph is known as the power function. The power curves drawn to the right compare the nth root of different numbers. So for this curve here, y equals x to the power of a half, which is the same as y equals the square root of x. For the blue curve here, y equals x to the power of 1/3 is the same as y equals the cube root of x. And for the red curve, y equals x to the power of 1/4 is the same as y equals the 4th root of x. There are many more complex examples of power curves. The ones above are very simple, but they serve to illustrate a very common example. Here's a quick quiz to help you. Please check through the video at any time. The answer to the quick quiz, midnight. I think that's very straightforward, isn't it? Here are the answers to the quick quiz. and the video is there to help you at any time. If you found this video useful, please subscribe on the next slide. You will receive a notification when the next video is available. Hope to see you next lesson.